All right, let's go ahead and take a look at your homework that you had last night or over the weekend. Page 138, practicing with inequalities. You had 12 inequalities you were supposed to solve. You were not required to graph them, though if you did, that's extra practice for you for sure. Page 138, numbers 5, 6, 8, 9, 14, 15, 16, 26, 27, 35, 36, and 39. Want to see how you did on those, and then we will take that quiz. Noah, it did not escape my notice that the one time I announce a quiz, you're not here. Anyway, I'm sure you're sick. But anyway, if you are actually not feeling well, I hope you start doing better and are back with us tomorrow. But anyway, page 138, let's take a look at those dozen inequalities that you had to solve. Good. Now he shows up. So where's the work?
I tried to do it in my head.
Why?
Because it was late.
This morning?
Last night.
Mm-hmm.
And that's why I couldn't use it.
Mm-hmm. Well, tell you what. If you got at least 7 correct, I won't give you a homework offense for not showing your work. But if you didn't get at least a little over half right in your head, then I'm going to consider it slopped down last minute incomplete. All right, so does that sound fair to you, Maddie? I mean, if he gets at least a little over half right, I can't possibly give him a homework offense for not showing his work, because he did it with some degree of accuracy, right? Normally you don't show your work. That's just, no. That's a failure. So, why don't we go ahead and trade, and we'll grade these.
Grade them?
Just you check them. Now, if you did fantastic, wouldn't you like to grade it? Of course you would. All right, so let's see how we did here.
Uh-oh.
Yeah. All right, get your pens out. Let's go. Now, Noah's like, I'm glad I'm not there. Now, I'm sure you did a great job. Very thorough work, right? And Gavin's like, that slob, I can't believe him. All right, number 5. X is greater than or equal to 9. Number 6. X is greater than or equal to 11. Number 8. X is greater than or equal to -6. Number 9. Finally, x is less than something. X is less than 9. On number 14, x is greater than or equal to 7. Back to our old ways. Number 15, x is greater than or equal to -12. Now, on this one, you might have had -12 is less than or equal to x. Okay? Probably didn't want to flip that one around, but anyway. Number 16, x is less than or equal to 4. Number 26, x is greater than 8, or you probably had 8 is less than x. Number 27, x is greater than 11. Number 35, x is greater than 0. Number 36, x is less than -11. And number 39, x is less than or equal to -11. All right, Brecken, how'd she do out of 12?
1, 2, 3, 4, 5, 6, 7, 8.
8 out of 12? Okay, not bad.
Hold on. 1, 2, 3, 4, 5, 6, 7.
He got 7 correct. All right, you dodged the homework offense. All right. All right. So I will give you credit that you actually did put some time and effort into it then. I have to give you that. So rather than just blanket no work, automatic homework offense, which is what my gut would normally be to do to you. But anyway, not just to you only, but to anyone, including Noah. Gavin, except I can't check his homework anymore, unless your mom starts sending me pictures. I might ask him. And Maddie, of course, I would do it to her as well. All right, let's take a look at the ones we missed and make sure that we understand what we should have done so that on the quiz coming up here in just a moment, we don't botch it. All right, so let's see. Maddie, you missed 4. Which 4 did you miss?
9, 15, 16,
9, 15, 16, 39. All right, so let's take a look at that very quickly. Number 9, Maddie, we should have started by moving the -8 over as a +8. Did you get 7x less than 63 for your second step? So just dividing away the 7x is less than 9 is division error. You forgot 63 divided by 7 equals 9? Oh, okay, there wasn't a less than or equal to symbol on 9. You might have seen the symbol from maybe from number 6, perhaps. All right, so otherwise good. You said number 15 was the next one. All right, 101 greater than or equal to. Did you combine to get -8x, +5? All right, and did you do a double switch or did you send the 5 over? You sent the 5 over as a -5 to get, what is that, 96 greater than or equal to -8x? All right, divided away the -8 to get -12. Signs are different. Forgot it, but did you actually write the negative when you showed the division? Okay, so remember, if it's a negative, you got to divide the negative away to get to the plain old x. And in so doing, we also have to flip that inequality symbol around too, don't we? So a couple little things there then. Number 16, I assume you combined the x's to get -3x, +3 greater than or equal to -9? Okay, did you double switch the x and the 9, or did you just send the 3 over? Okay, and when you did, sent it over as a negative to get -12. All right, probably same thing. We cannot divide by 3, we must divide by -3. That way the negatives and the 3's cancel. Here the negatives also cancel, giving us just 4. And then we have to flip it around and say less than or equal to. I'm assuming you had -4, and you also did not flip the inequality? You did, even though you didn't actually show dividing by the negative. Okay, did you show your division step at all, or did you do it in your head? I would encourage you, particularly with the negatives, show the division. Normally we do it in our head, but with negatives, it's just annoying. And that's one reason why I might suggest the double switch. Because you move the 9 over as a positive, you move the 3x over, now you can do the division in your head without screwing anything up. But especially with negatives, I would show the division step. It just keeps you from making mistakes. And then 39 is going to be a similar situation, right? You distributed the -7 to get -14x and -21. Okay, so distribution was good. Greater than or equal to 133. I'm assuming for you, you went ahead and sent the 21 over as a positive to get the 154. And what should you have done next? Divided away the -14 to get x is, there we go, negative, and then it goes in one time, one left over, and goes in one time there. Brecken, which 4 did you miss? Or which 5, excuse me, did you miss?
All those on the board and 36.
Okay, so you happen to miss 4 of the same 4 sheeted plus 36 as well. Number 36, when you distributed, did you get 21 negative? Well, you didn't do your work, so should have distributed to get 21 negative 15x greater than 186. In your head, then, sending the 21 over as a negative to get negative 15x greater than 165, dividing in your head by a negative 15, not the positive 15. Cancel with the 15 and the negative to get x is less than, flip the inequality. 15 goes into 16 once, 1 left over, 15 goes into 15 once, but don't forget, positive divided by negative is negative, and there would have been our answer. All right, questions on these? All right, clear desk, except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil, everything else away. First and last name at the top of your paper, along with today's date, which is 3/8/21. 3/8/21, today's date. First and last name, 3/8/21, today's date. And this is quiz 26. Quiz 26. First and last name, 3/8/21, today's date. And this is Algebra 1, quiz 26. Let's take a look at the quiz very quickly together. Number 1, a little bit of a review on how to graph inequalities. So for 1, 2, and 3, go ahead and draw a number line and graph each of those inequalities. Number 4 and number 5, just rewriting each of those statements algebraically as an inequality. And then for 6 through 10, solving the inequalities. And then there's a bonus for you as well. Be sure to show your work on numbers 6 through 10. All right, you may begin. Just about another minute or so to be finishing. All right. Well, if you need to pause the video to give yourself just a little bit more time, then you may do so. Otherwise, let's go ahead and continue in your textbooks, page 141. And at the end of the hour on Friday, we'd begun looking at word problems that involved inequalities, where we basically are going to approach them the same way we would have done before, right? You pick an unknown to be x, you represent the other in terms of x if there is more than one unknown. In several examples we looked at, there was only the one. But instead of using an equal sign, you have to pick which symbol you're going to use when you get to your verb. Let's look at several of these together, and then you'll work a few more for homework tonight. Page 141 in your textbooks, if you'll be turning there. And Brecken, if you'll go ahead and read number 5 for us.
Mr. Harris wants a yearly interest income on his 12% investment to be greater than $6,000. How much should he invest to earn more than $6,000?
All right, so this is a lot like what we've been doing, right? This is simple interest, except there's not 2 different interest rates, there's only one. So we'll just use our simple interest formula, Maddie. I equals PRT, or the way we usually do, we kind of flip it around, don't we? And we say that PRT equals I, correct? Now, we did say that the T will generally drop out if time class is 1 year. And what is the time in this particular problem? 1 year. It says yearly. So for our purposes, we can say that PR equals I. And so we want to know what is his interest income, right? And so we need to take the principal, which is the amount of money he's going to invest, and times the rate, and that's going to equal the interest he wants to get, correct? I don't know the principal, right? It says how much should he invest? He wants to make at least $6,000 a year, make more than $6,000 a year, I should say, but we don't know what the principal is, class, so we should represent the principal as X. And we do know his interest rate he's earning on this particular investment, Brecken, is
12%.
But I'm not going to write 12%, I'm going to write, and you realize this is the interest he will earn, correct? 0.12 times X is his annual interest. And he wants his interest income, Maddie, to be, does it say greater than or equal to 6,000? It says greater than. It says more than. It never says or equal to, right? So what symbol should I use? Just a greater than, not the or equal to. Do you see that? Right? Had it said at least 6,000, or greater than or equal to, or more than or equal to 6,000, then I would have used that or equal to symbol, but as is, we won't. And there, not an equation, my inequality for this particular word problem. Does that make sense how to set that up? You think through it like we would have done with any equation. It just happens to not have an equal sign. It happens to have a greater than symbol. And we would solve it, though, like we would anything. What would we do now to solve, Brecken? Yeah, let's start by moving that decimal over 2 places. Now, this is all one term, so I do not move it 2 places here and 2 places here. If they were separate terms, I would, but it's all one, so I just move it 2 places, either with the x to make it a 100x, which would be stupid, or I move it 2 places with a 0.12, which is the whole point, Brecken, to get. So really, this becomes, or in other words, 12x. This is another term in the inequality. I need to move it 2 places there as well, Maddie, to turn it into 600,000. And then, of course, class, we simply divide away the 12 from both sides. And, of course, we know that 12 will go into 60. How many times evenly, class? 5. And then it'll be all zeros left. So, obviously, here, the x has to be greater than $50,000. In other words, if this guy wants to make over $6,000 a year, he has to invest over $50,000 a year, right? So it does me no good to be like, you know what? I would love to make $50,000 a year without doing anything. So I want that much interest coming in. Well, yeah, but you got to invest a certain amount to make that happen. I ain't got a certain amount, so I'm never going to make that much interest. So he needs to, if maybe he has $50,000 lying around to invest, more power to him. If he does, throw a little my way. But anyway, he has to have at least $50,000 invested, or more than $50,000 invested, if he wants to make more than $6,000 on this investment. Questions on 5. Read number 6 for us, Maddie. Oh, careful. Got to read very carefully here. Very different, right? All right. Now, that kind of misunderstanding caused real problems, right? Eat at least 2,900 calories a day. I am on it. Unfortunately, it's not going to get you real far. Now, I will say, depending on how active you are. I mean, I was in high school. I was a runner. I was running, 5-6 miles a day. So I was eating about 4,000 calories a day because I was burning 4,000 calories a day. Now, you don't need to eat that many. I keep telling myself. All right. So anyway. So assuming that Trevor is a reasonably healthy individual who eats how many meals a day, class? 3, right? That would be healthy, right? Health class. You're not in health. No, you are. 3 meals a day for better health, okay? And the 3 meals a day, class, are breakfast, lunch, and supper. You might call it dinner, okay? So if we take breakfast plus lunch plus supper or dinner, we'll say dinner. He's got to stay at most 2,950 calories. How would I say at most, Brecken? And then less than or equal to, in his case. It sure would have been easier if he just said at most 3,000 or just stay under 3,000. You know what I'm saying? Why? 2,009, why? Because I guess it sounds cooler. Anyway, well, we know how many calories he got for breakfast this particular day, Maddie. He had 850 calories for breakfast. Plus, for lunch he had, okay. All right. We got to learn how there's a key word in there that I don't know that I've taught you guys. It's the word respectively. So if I were to say that Matty and Brecken are 5'6" and 5'8" respectively. I don't know if those are really your heights, but let's just make it up, right? 5'6" and 5'8" respectively. The first number that I mentioned goes to the first person mentioned. I mentioned Maddie first, so the 5'6" goes with her. I mentioned Brecken second, so the 5'8" goes with him. Does that make sense what respectively means? So there are 2 meals listed and there are 2 numbers listed. Breakfast and lunch provided 850 and 932 calories respectively. So breakfast is the 850, lunch is the 932. Does that make sense now? Okay, maybe a term that I hadn't taught before, so I want to make sure I explained it. By the way, when you get to geometry in a couple of years as juniors, that's going to be a term you're going to see a lot, is the term respectively. So it bears learning here. Now, dinner is the question, right? He gets to dinner, he's like, I wonder how much I can eat. And can we go buffet here? Maybe, maybe not, So we're going to represent dinner, class, as X. You could leave it as a D, but I'm just going to write it as an X. And so we'd say that 850 plus 932 plus X has to be less than or equal to 2,950. Now, this class would typically be a mental step. This would not typically be something I would write down. This is me thinking, okay, breakfast, lunch, dinner has to stay under or at, less than or equal to, at most, 2,950. So in my head, I'm thinking this is what I actually would write on the paper. Does that make sense? And to solve, what would I need to do here? Maddie. To get?
So 1,782.
Good. So far, he's already had 1,782 calories heading into dinner. And remember, he's allowed 2,950 as his absolute maximum. So what do we do now to solve for the X? And when we do, we're going to get hit at most. He's allowed to have less than or equal to, probably should be less than, right? Especially if the doctor's talking to him about calorie intake. Okay, that probably means he should be staying less than this. But at most, he should have
1,106.
There we go. At most, 1,168 calories. Now, I will say, if I'm the doctor, I'm not only giving him a recommendation about how many calories he should have, but I'm probably also giving him a recommendation of when he should have the calories. For instance, you eat the calories at dinner. What do you do after dinner? Sleep. Do you burn calories when you're sleeping? Not many. You burn some, but very few. All right, now, when do you burn most of your calories? During the day, while you're doing stuff, right? What meal starts your metabolism? Whatever meal you eat first. For most people, that should be breakfast. So he's actually got it exactly upside down. Most of the calories should be at breakfast. That starts your metabolism and gives you energy all day. Lunch should be the middle meal, and the smallest meal of the day should be dinner right before you go to bed. He's upside down, like so many Americans, and we wonder why we're fat. Okay? I'm looking at you, Noah. All right. I'm kidding, of course. Anyway, questions on this? Now, I'm not kidding about eating the biggest meal of the day as breakfast, though, by the way. That should be your biggest meal. So people are like, oh, eat a granola bar. You wonder why you're tired all day? Calories equal energy. No calories, no energy. Anyway, you eat a lot at supper time. Like, I wonder why I can't sleep. Put all those calories in, doofus. Brecken's like, why does he keep looking at me? Anyway, number 7. Go ahead and read this one for us, if you would, Brecken.
The borrowers are going camping and their budget allows them to spend up to $600. If the tent costs $129.47, the camp stove is $32, the fishing equipment is $52.45, the groceries are $167.25, and additional supplies $76.30. How much can they afford to spend per night for the campsite? If they plan to camp for 6 nights, round down to the nearest dollar.
All right, so there's a whole bunch of expenses up front, right? That's kind of what all these numbers are. What do you think we're going to have to do with all these upfront expenses, class? Let's add them together and get one total number real quick. Rather than writing an insanely long inequality that lists all of the numbers individually, we know we're going to need to add. It's easier to add when you line them up in a nice, neat column anyway. So go ahead and add them together real quick. Let's find out what their initial expenses, what we could call their supplies expense. So the tent, the stove, fishing tackle, the groceries. They're going to spend 6 nights on that amount of groceries? Wow. Additional supplies. Okay. You'll double check me here once you get it. Let's see if we all got the same thing. We should be so lucky. Moment of truth. Did you get this, Maddie? You didn't. One of us is wrong. All right, I'm going to double check my work here. Make sure it's not me. Did you get this? He's running out of fingers. All right. I'm getting this again.
I got that.
You got that. Yeah. He kept a straight face when he said it too. That's pretty good. All right. I'm picking on you, Brecken. Okay, so let's just say, let's roll with my number. Let's say I'm right, just for sake of argument, since my book doesn't actually tell me. Worthless piece of... Anyway, so we're going to assume this is right, and Noah and Gavin are like, yeah, I got it. Put your calculator away and add it like the rest of us, okay? Anyway, so let's just say this is how much they spent on supplies. Okay, unless they own their own land, which... let's assume they don't, they have to pay for a campsite, as the problem says. Every night you spend on the campsite, you spend a certain amount of money renting that spot. So they're going to be there for 6 nights. We don't know how much they're going to be able to spend on it, right, Maddie? But we could represent the amount per night as X, because we don't know what it is. But if they're going to spend 6 nights, I should represent the total amount spent on renting the campsite as 6x. So 6x is to rent the campsite, plus the $457.47 that they're spending for all their supplies up front. And that all has to fit within a budget of $600. Now, what does that mean? If they set aside $600 that they're able to spend, then I need to set that less than or equal to. Not just equal to 600, because hey, if you can get out of vacation spending less than you planned, that's good. Okay, that means you actually have money for other things later. So less than or equal to 600. Do we see how to set up the inequality, how to think through these problems? Just like before, except not an equal to, but less than or equal to. So first thing, of course, we need to do is to choke and die. No. First thing we need to do is subtract the 457.47, then choke and die. Okay, so we subtract the 4, only if you're breathing. Don't die, Maddie. I don't know why I'm in such a mean mood. I'm sorry, Bracken. I love you too, okay? It's just, you're fun to pick on. All right, so we subtract away check your subtraction, see if you got what I got. Brecken's like, yup. You didn't write down the problem yet. Just kidding. He did. He worked it out. I'm just giving him a hard time. Noah's like, yeah, I don't believe it. I think you. Anyway, did you get this, man? All right. And now, of course, class, we need to divide away the 6. So we divide both sides by the 6. And let's do this together. 6 goes into 14. 2 times with 2 left over. 6 goes into 22. Almost 4. 3 times, though. Yeah, leaving us 5. 4, you're right. 4 left over. 6 goes into 45. 7 times with 3 left over. And 6 goes into 33. 5 times with 3 left over. 6 goes into 30. 5 times. Now, obviously, something looks a little funny about the money here, right? $23.75. He says, let's round to the nearest dollar. However, it does give you a little hint. It says round down. Because for us, now normally we would look at this and say, well, that rounds to $24. But if they spend $24, they're going over budget, right? So since it's a less than or equal to, when we round, even if this were $23.99, I'd say flex your budget 6 cents, okay? But anyway, if you're cutting it that close, you're in real problems. But since technically, if they're like, we definitely cannot possibly spend more than 600, we would have to say they have to spend no more than $23 a night. All right, $23 a night would be their limit. Again, assuming nearest whole dollar. Nearest whole dollar, since we had to run down. Questions on number 7? Let's get down to number 9 right below it. Read this for us if you would. Maddie's turn, right? Maddie, number 9.
Each chair installed in the chapel requires 24 inches of clearance. If each row cannot be greater than 35 feet, then what how many chairs may be placed?
All right, so our auditorium, for instance, has pews. Does your auditorium at your church have pews or chairs? You have some of both. Okay, I guess technically we have some chairs and spots. Mainly pews. Okay, so the nice thing about pews is you can pack people in as tightly as you need to. The downside of pews is people don't like to tightly pack. So, unless they're dating, then, anyway, that's a whole other issue that we got to address. But anyway, so chairs, right? So there's some auditoriums have chairs that are like narrow, and then other auditoriums have like nice wide chairs. Give you a little bit of room. That's what these are, 24-inch chairs. This is great. We're doing good. If you really got it, then just take up 2 chairs, okay? Anyway, so we want to put chairs on the row, and the row cannot be longer than 35 feet. Now let me say this again. Each chair takes up 24 inches, but each row cannot be greater than 35 feet. Does anyone see a problem? Yeah, so what's the problem? The units don't match. We got to make a match, right? You can't put inches and compare that to feet. So let's, which one's easier, to turn 35 feet into a whole bunch of inches or turn 24 inches into a couple of feet? Yeah, how many feet are in 24 inches, class? 2 feet, right? Oh my. And you even went here all the way through. I'm telling your grandmother. She would hang her head. Did your grandma actually teach you though? No, I think she retired the year before you. I understand now why she retired. I wondered at the time. Anyway, so 2 feet, right? Each chair takes up 2 feet. Okay. The question is, how many chairs? Well, we don't know how many chairs. So let's call the number of chairs X. And if every chair takes up 2 feet of space, then we would represent all the chairs put together, all the space they take up, as 2x. X chairs, 2 feet a chair, 2x feet of space by all these chairs. But it says these chairs, the row of chairs cannot be greater than 35 feet. Cannot be greater than. What does that mean? Less than or equal to, right? Cannot be greater than means less than or equal to 35 feet. Pretty straightforward. And we divide both sides by 2. What do we get? $17 and a half, right? So in other words, the row needs to have less than or equal to 17 and a half chairs. Anyone see a slight problem with that answer? That half a chair is going to cause real problems, especially since usually 2 legs are on one side, 2 legs on the other side, and no legs in the middle. So if you got a half a chair, you're going to have a hard time sitting in that thing. So probably we need to round to the nearest whole chair. Do we round up or down? Why? Because it says less than. Had it said, oh, greater than, I would round up to 18. Since it says less than, we would say that the row should have no more than 17 chairs at most. Fewer than that would be fine, but 17 chairs at the most in the row. Questions on that? Let's go down to number 13 now. Jumping all the way down to number 13. And read this for us, if you would, Brecken.
James has scores of 78, 89, and 90, and 96 on her first 4 tests. What score should she make out of 100 points in order to have at least an average of 90?
All right, so Jenny's like, I really, really want an A. And on her first test, she gets a 78. Now, that is not setting her up well for success, right? And then her next test, she gets an 89. She's still not quite making it. Then she finally gets a 90. It don't look good. Then she gets a 96, and suddenly it's like, maybe there's hope. Things are definitely trending in the right direction, right? Constant, steady improvement here. What would she need to make on the 5th test in order to get that A average? Well, what do you think we should do? How do we average things? Okay, so if we were to add all our tests together, what would that look like? Well, but there's one thing you can't add in, and that's the 5th test that we don't know, which we have to call X. And those all would have to be divided by 5, since there are 5 of them. Now, to add these together first, like we did last time, I did that mainly because there were crazy decimals and stuff, and here, these might not be quite as hard to add, and there's not as many of them. But we add them all together, divide by the 5 test total, and that needs to be at least a 90 average. At least, Maddie? Greater than 90? She would take the 90, right? I mean, that was, I'll be honest with you, in college, that was like, I need the 90. Give me the 90, keep my 4.0. So greater than or equal to 90 would be acceptable, right? And of course, I don't like fractions. Do you like fractions? I hate fractions. So let's multiply everything, and this is all one thing, by the way, and this by 5. At the same time, let's go ahead now and add, as Brecken was doing, the 78, 89, 90, and 96 to get That sounds right. 353. Fact check, Maddie. Give you 20 seconds. Yep. And then is greater than or equal to, notice the 5's canceled away. I started to draw the fraction, I was like, wait, we got rid of the 5. And that's, I'm not sure why I made a dollar sign there. That's supposed to be a 5. I just like money. 5 times 90? 450. And then, of course, we have to subtract away the 353 to get that her 5th test score needs to be greater than or equal to 97. She needs to make at least a 97% on the next test. Now, does that seem feasible? Well, she got a 96 on the last one. Things are definitely trending up, so she very well may get herself a 97 and pull off that A, even though it looked pretty bleak before. Turn the page, and next section in your notes. Turn the page and go to the next section in your notes. Compound inequalities. Compound inequalities. An inequality that we've been working is anything bigger than this, anything smaller than this, anything but this. But you understand in a lot of cases there's limits on things. I was looking for a house several years ago, and I was like, well, I can't spend more than this much, but if I get a house that's less than this much, it's probably going to be junky. I don't want a junky house, but I also can't afford a really nice house. So when I was searching on homes.com, which does not endorse my YouTube channel, but if they did, I'd give them a plug. But anyway, while I was searching, I set limits. I said, I don't want to spend less than this, but no more than this in the search box. There's an upper limit and a lower limit. So for instance, let's just say that I would search for, and this is obviously the housing market's changed, but if I said I want between $80,000 and $120,000 for a house. Well, we would say that anything in between here would work. Well, to show in between, I just put an X in between them. And this X would have to be less than, or perhaps equal to, the $120,000. But it would have to be greater than or equal to the $80,000. Now, notice that they are less than or equal to symbols in each time, but from the X's perspective, less than or equal to 120,000, greater than or equal to the 80,000. Does that make sense? If Brecken's looking for a used car because he crashes his pickup truck, I'm not a prophet, so don't fear, but if he's looking for a used car, a new pickup truck or something, it's like, well, the cheapest pickup truck that would probably still run might be like $4,000. Cheaper than that, it's probably a complete hunk of junk, it's not going to run, right? But you're poor and your dad's like, I'm not buying you another shiny new pickup truck. So $10,000 might be your upper limit. Well, let's say we didn't actually want to spend $4,000, but we also didn't want to quite spend $10,000. We wanted to be between those, but not equal to them. Well, I could write $4,000 less than X less than $10,000. And using K because I'm too lazy to write all the zeros, right? If we were to say that Maddie's looking for a used car here in a few years, her parents are like, we want to get you a car, Maddie, but we're not buying you something new because, number one, that's too expensive. Number two, we're not sure if you're going to be a good driver or not. Have you taken driver's ed yet? Fixin' to. Okay. All right, that's a good southern term, fixin' to. And so they're like, okay, we know anything older than like 2010 is really old and probably no good. But anything in the last like 5 years is going to be too expensive for us to want to spend on Maddie's car. So maybe let's search between a 2010 vehicle and a 2016 vehicle. Maddie, where would we put the X? And if we were willing to take a 2010 vehicle, what would we put here? Less than or equal to. Now, from the X's perspective, it's greater than, but it's actually a less than or equal to symbol. And then 2016 is the newest vehicle we feel we could afford to spend on you for your new car. Another less than or equal to, right? What if we were talking about teenagers? When do you become a teenager, class? When you turn 13, on your birthday, right? You become a teenager. When do you escape teenager status? Nope. On the 20th birthday, you are no longer a teenager, correct? So a teenager is anyone between the ages of 13 and 20, including 13, Brecken, but not including 20, but right up until you turn 20. Does that make sense? This is what we call a closed interval. It has or equal to symbols. If you go to write that term here, it's a closed interval. Has or equal to for both upper and lower limits. This would be another example of a closed interval. Has the or equal to on both the upper and lower limits. This is what we call an open interval, where neither value has the or equal to. And then finally, this interval here is what we call a mixed interval, a mixed compound inequality, because one of them has or equal to, the other doesn't. Now the reason for these names you'll see at the bottom of page 142. Look at the first compound inequality. -2 is less than x is less than 3. Notice on the number line, there's a circle, an open circle at -2. There is an open circle at 3, and they've shaded everything in between. Hence they call it an open inequality. Whereas the second one has a closed-in, filled-in dot at the 1, a closed-in, filled-in dot at the 5, and shades everything in between. Again, x could be any of those numbers in between there. You see the mixed one has this open circle at the -1, the closed dot at the 2, or maybe a solid dot at the 0 and an open circle at the 4. If there's one of each, that would be considered a mixed inequality. Questions on those? That's what we're going to be looking at more tomorrow. For homework this evening, I want you to read over pages 142 to 144. For homework this evening, I want you to read over pages 142 to 144. I want you to read about these compound inequalities so that you'll be ready to go for what we're doing tomorrow. Read pages 142 to 144. In addition to that, I want you to do on page 141, word problems 8, 10, and 11. Word problems 8, 10, and 11. And on page 142, do numbers 1, 3, 5, 7 through 10. 1, 3, 5, 7 through 10. Take a look at that homework. We'll also take a look at your quizzes tomorrow. And of course, we will continue working on compound inequalities tomorrow. Have a wonderful rest of your day. You are dismissed.